Hello everyone, my name is Kenny and I'll be introducing and taking a deeper dive into trigonometry by exploring what a trig function really means and how to correctly identify and utilize each component. Let's get right into it. After covering today's learning objectives, we'll be able to draw a triangle to represent any trig function, solve for other trig functions when given an existing trig expression, and finally solve for any missing angles or sides of trig triangles. Now let's move on to some important definitions and concepts we will need for this upcoming presentation. Firstly, SOHCAHTOA. This acronym is one of the most important concepts to remember in trig. This helps us to remember which sides each trig function correlates to. And as we can see with the hint, SO can be interpreted as sine is equal to the opposite side of angle x divided by the hypotenuse of the triangle. And using the same logic, we know that cosine is the adjacent side divided by the hypotenuse, and tangent is the opposite side divided by the adjacent side. In this example, if we know that side A and O are equal to 5 and 7 respectively, then without any calculation, we know that the tangent of angle x is the opposite side divided by the adjacent side. Thus, it is equal to 7 over 5. And next we have our term reciprocal. The reciprocal of any number, to put it simply, just means the inverse. A hint that you can always use to double check your work is to multiply the number and its reciprocal, and it will always be 1. Looking at the example, to find the reciprocal of any number, we just need to reverse the fraction. So 5 becomes 1 over 5, and 3 over 4 becomes 4 over 3. Next, we have the Pythagoras theorem. Its standard form is a squared plus b squared is equal to c squared. This formula is only utilized when we know two sides of a right triangle and are trying to find the missing third side. In the diagram, c is always the hypotenuse, which is always the diagonal or the longest side of the triangle. A and b are the adjacent and opposite side. It doesn't matter which variable is assigned to which side, only the c variable matters. In the example problem, we are given the adjacent side and hypotenuse side of angle x. To solve for the missing side, we plug in 10 for the hypotenuse and 6 in for either a or b. Again, they're interchangeable. After substituting the values and simplifying, the resulting value is positive or negative 8. However, if we look at our triangle, the b side is traveling upward, indicating that its value is positive 8. And the final concept to understand is inverse trig. Similar to other functions, we swap the x and y values of the trig expressions. However, unlike normal inverse functions, they have designated names. The inverse of sine is arcsine, cosine is arccosine, tan is arctan, and so on. We can use inverse trig functions when we're given two sides and are looking to find the correlated angle. In our example, assuming we still use the triangle above, we are given the values of side A and C, which are 1 and 4 respectively. Our goal is to solve for angle x. Looking at our diagram, we see that with respect to angle x, side A and C are the adjacent and hypotenuse sides respectively. The trig function that correlates to the adjacent and hypotenuse would be cosine. So with this in mind, we would take the inverse of cosine, arccosine, and use that function to solve for angle x. By substituting what A and C are into the arccosine function, we get an angle of approximately 75.52 degrees. Understanding which trig functions to use and what variables to solve for is difficult to comprehend, but a method that I first started using utilizes a combination of both visuals and logic to more easily understand trig diagrams, also known as the bow tie methodology. Firstly, we want to draw a bow tie shape with the center of the diagram passing through 0, 0, also known as the origin. Next, we will draw 4 angles, all of them being adjacent to the origin, and using this diagram, we would then use them to identify which quadrant our trig function is referring to. And finally, we would isolate that one quadrant and solve for all missing variables. Now, this may first seem complicated, but the following slide and example will walk through every step, and hopefully with the addition of visualization, these steps will become much more logical. So let's walk through the bow tie methodology. So we are given this problem where we're given cosine of x is equal to 4 over 5, and we must find the unknown side. So our first step is to draw the bow tie methodology. So as we can see here, we have our empty coordinate plane. So what we're going to do is just draw our diagram or our bow tie. As you can see, it looks exactly like one or close enough. And what's important to note in this example is that just like our previous slide stated, the bow tie will always pass through the origin or the 0, 0 point. Our next step is to draw the 4 corresponding angles. As we can see marked in red, these 4 angles will be indicative of where the origin is. So as you can see, they're all adjacent to that 0, 0 point. And what's important to note is that step 1 and 2 will always be the same, no matter what type of trig problem you're doing. So we can switch the cosine out for sine or for tangent. We can even throw inverse in there. We can change the values of the two sides. Step 1 and 2 will always be the same if you're using this bow tie methodology. Our third step is to identify which of the four quadrants we'll be working in and isolate that. So a nice trick I like to use is another acronym. All students take calculus. They go by many different names. This is the one I'm more familiar to. And what this means is that the letter that each quadrant has currently is indicative of what trig function is positive. So for example, in quadrant 1, A means all trig functions are positive. In quadrant 2, that means only sine is positive, and cosine and tan are negative. So in this case, since we know that our cosine function is 4/5, which is a positive value, we are going to be sticking with quadrant either 1 or 4. Our fourth step is to isolate the triangle and solve for any unknowns. So in this case, we will be isolating quadrant 1. And the reason that we do that, before we continue on, is because if we look at our trig function, cosine is equal to 4/5. We know that cosine, based on our SOHCAHTOA, is adjacent over hypotenuse. So adjacent is positive 4, and the hypotenuse should be positive 5. We can see adjacent side to this red angle in quadrant 1 is going to be that horizontal side, which is positive for both 1 and 4. However, if we look at the hypotenuse side, in quadrant 1, the hypotenuse, or the diagonal, the longest side, now that side is going to be positive in quadrant 1 and negative in quadrant 4. And for that reason, we're going to select quadrant 1 to work with for this problem specifically. And now all we're going to do is label the unknowns. So our red angle is going to be x, our adjacent side, our horizontal, is going to be 4, our hypotenuse, our longest side, our diagonal, is going to be 5, and we're trying to solve for the vertical side, which we're just going to name y for now. To solve this, we're going to use the Pythagoras theorem, another introduced term. A squared plus b squared is equal to c squared. Again, 4 can either go in for a or b, those are interchangeable, but 5 must go in for c, which is hypotenuse. So after we plug in our 4 and 5 value, we're just going to do some simple simplifications. We're going to move the 4 squared over to the other side, expand out the powers, and solve. Our final answer is going to be root 9, and y is equal to positive negative 3. And now we need to do one last step because we only have one answer, we can't have two, and that is to determine whether our vertical side is going to be positive or negative. And as you can see in our graph, the y value in quadrant 1 is going up. It's starting from the bottom and vertically reaching up. So that means our y value is going to be positive. So in this case, y is going to be positive 3. Now let's solve for example 1. So we are given the trig function sine of x is equal to 3/7. So our first step is to solve for what quadrant x is currently in. For this step, I want us to think of the unit circle. So we have a very clear boundary or restriction that x is an angle that's between pi over 2 and pi. So if we think back to our unit circle, or you can directly convert from radians to degrees, that is 90 and 180 degrees respectively. And if we think about that on our graph, that is exactly equal to quadrant 2, or that's where our angle is going to be residing in. Our next step is to, of course, draw the triangle. I'm going to directly isolate it in the second quadrant, and we can see labeled in red, that's going to be our angle, which of course, as we mentioned before, is going to be adjacent to that origin, that 0, point. And now we're going to label in our unknowns, 3 and 7, and our x, which is what we're trying to solve. Now, just like our previous problem, we're going to use a Pythagoras theorem in order to solve for that missing side. So again, it doesn't matter if we interchange a and b, they're the same. By hypotenuse, which is the 7, the slant, must always be our c value. After moving some variables around and simplifying it, we get that x is equal to square root of 40, which is also, once we simplify it, equal to 2 root 10. Usually when we solve these trig functions, there is a possibility of factors canceling out, so we always want to simplify to the simplest form. And now what's interesting is that we want to look back at our graph. We are solving for this missing side x. However, since we're in quadrant 2, with respect to the origin, our 0, point, we can see that our x is actually moving away and more towards the left. So that means our actual answer to the length of x is going to be negative 2 times root 10. And now, finally, we want to solve for cosine of x. Now, we know that cosine of x is equal to the adjacent over the hypotenuse side, which in this case, we already have the triangle all drawn out. So in this case, our adjacent side is negative 2 root 10, and our hypotenuse is, of course, 7. So once we put these two angles together, we don't need to solve for anything else. This is already simplified, and that is our answer for cosine, -2 root 10 over 7. Now let's move on to our final example, example 2. We are given that cotan of x is equal to -7 over 9. So the first thing I have to do is to take the non-inverse form of cotan, because it's an inverse trig. That will be tangent. Now, the cool thing about inverse trigs is that they're reciprocals. So we can just rewrite cotan of x is equal to -7 over 9. We can rewrite that as tan of x is equal to -9 over 7. Our first condition is to find the quadrant again. So just like previous problems, we're just going to think of the unit circle, or we can directly convert from radians to degrees. So in this case, our boundary is from 3 pi over 2 and 2 pi, which is equal to 275 degrees and 360 degrees respectively, and that will give us our quadrant of quadrant 4. Next, we would want to visualize our triangle. So this triangle is going to be in quadrant 4 using the bow tie methodology. That's labeled in blue. Our angle is going to be labeled in red, our x. And our next step is to put in our unknowns. In this case, we are working with the tangent function. That's going to be opposite over adjacent. So that's going to be -9 and 7. Now the negative sign, that can be intuitively found out by just taking a look at our triangle. We can see that our 7 is moving from left to right. Our -9 is moving from top to bottom. So that means our opposite side, our 9, is going to be negative. Now we're going to solve for that missing y, our hypotenuse, by just, again, using the Pythagoras theorem. And after simplifying, moving some numbers around, we get that y is equal to the square root of 130. And now what's next is that we do want to solve for the angle itself. We're going to backtrack to step number 3, solve for the angle x. How we're going to do that is that we're going to use inverse trigs. So we know that we are given the sides for a tangent, which is going to be -9 over 7. In order to backtrack and solve for the angle instead, we're going to plug our side value, our -9 over 7, into our inverse trig of tangent, and we get a value of 52.125 degrees, and we're just going to round that to 52.13 degrees. And that is going to be our x value. And finally, we want to solve for secant of x. Again, just like our previous problem, we already have the triangle drawn out. Secant of x is the same thing as 1 over cosine of x. In this case, our cosine of x is going to be adjacent over hypotenuse. So we can rewrite the fraction as 1 over adjacent over hypotenuse. And that in itself is going to be equal to 1 over our adjacent side, which is going to be 7, over the hypotenuse, which we just solved to be root 130. And now if we take the fraction of a fraction, all we do is just flip the numerator and denominator, and our final answer for secant is going to be root 130 over 7.